So we're here with Sean and Bunny, the creators of the Novena laptop project. And they were kind enough to take out some time from their busy schedules to talk to us about how it came to be. Thanks for being on the show, guys.
Hey, yeah, great to be here. Thanks for having us.
Yeah, thanks for having us.
No problem. So Felix, you were the one who brought this to my attention.
Right. Yeah, I saw your crowdsource campaign.
Yeah, crowd supply, right?
Oh, crowd supply campaign. I said, "Oh man, that is so amazing!" Because it was a dream of mine to make a laptop years ago before I could even solder. And then I saw your crowdsource campaign, and I thought, "Man, that's pretty amazing." So I kicked into that. I just got the board, but I've slowly built it up from there.
Great. Awesome. I'm excited that we've been able to enable you to get, to your dream of building a laptop, because that was actually kind of our dream as well. Is like, on my wall, actually, right over there, hangs the original Apple II schematics, which was the first computer I ever owned. And the schematics and sort of the Apple II's very accessible nature, it was put in my head that I should be able to build my own computer. And then, the 90s came along, and then computers became smaller and one chip, and then, the 2000 came along, they came in these little things you can't even take apart, and it just seemed to get less and less accessible. But, I think one thing that Sean and I really want to do was to try and wrestle that back a bit and see if we could build our own computer again.
Yeah, for me, I was coming from the Commodore side of things. We had a Commodore 64, which also came with the schematics, which was very common of computers in the early 80s. But during the 90s was really the heyday of when you would buy parts from the local hardware store and build your own computer from components, a motherboard here, a CPU there, a graphics card, before it became arguably more economical in terms of reliability to just buy a full machine with an operating system installed.
Yeah, the whole e-machine things around the turn of the decade really torpedoed that whole model.
Oh yeah, that's right.
I still build my own computers, if that makes you feel any better, because I want to know exactly what's in it.
Hooray!
And I had an Atari 800 back in the 80s, so I guess we have the trifecta.
Cool.
8-bit trifecta. Yeah, I see people, we get requests on our show. People are like, you should build a laptop. And that's really a loaded question because, you guys know how difficult it is. Everything is so miniaturized, and it's basically like a little strip of components along the top and mostly batteries. So you've made something that enables, hobbyists to create a laptop, and that's very cool. So do you have to evangelize to people like, hey, this is why it's so much more difficult to do this now than it would have been 20 years ago?
That's interesting. I
guess my question is, people are like, hey, I want to build a laptop, and then you are kind of having to say, well, it's difficult for X, Y, Z reasons you might not think about, but here is our Novena solution.
There's like two different sort of angles this comes from. So, like when we did the laptop ourselves, not intending to make it public, actually. And so actually the public kind of evangelized to us that we should make it available to them, right? Because people are like, wow, I can build my own laptop. I want to build it too.
Good projects escape.
Sorry?
Good projects tend to escape.
Yeah, they And then, but we were very hesitant on making that step to do the crowdfunding campaign because we're really worried that we would get people who were not aligned with the expectations of what we could deliver, right? And so we thought long and hard about how do we essentially find qualified users who were essentially ready to buy a car where you had to bolt the seat in and put the engine yourself, right? We weren't going to sell you like a fully assembled car. And the car would be kind of the speed of like a golf cart. It can get you point A to B, and it's a bit, but you have the whole, the plans are there. You built it yourself, right? That's the whole idea.
You're looking for the type of people who would have built a computer in the 70s now.
Yeah, basically, I guess. So one of the things that we did. So our first prototypes are actually sort of conventional clamshell shaped laptops that kind of would open like with a screen covering the keyboard that looked very conventional. And one of the big changes we did going to the campaign is we actually made it open in this backwards fashion where the screen comes up and the circuit boards are exposed on the inside. And that was done intentionally, partially because if you were the kind of person who was like, there are exposed circuit boards, what's wrong? Not like, there's exposed circuit boards, yes, right? Then you're not the kind of person who should be backing this project, right? So we did get a lot of flack from people who are like, I really wish you went with a more conventional design, a more accessible design, or whatever it was, and it was actually very deliberately done to appeal to people who really wanted to tinker with the hardware. That it said, I'm a hardware hacker, this is what I want to do, and not like, I just want to code on something that's pretty.
That's a smart approach. So you said crowdfunding, or what was the
Crowd supply?
Crowd supply.
Crowd Supply was the name of the website that did the
Yeah, I'm
funding
not actually
for us.
familiar with that one. Was that because of the location restrictions with other Indiegogo and Kickstarter, or was there a particular
No.
reason you picked it?
Absolutely. So I mean, unlike Indiegogo or Kickstarter, Crowd Supply is actually it has an explicit goal of being able to enable hardware products. So Kickstarter is like, we help people fund dreams, and after your campaign is done, the website goes away. You can't take more orders because the dream's funded, right? I mean, great. You should be able to buy it now. It's not really the case. So Crowd Supply, first of all, helps vets all of the creators' ideas, make sure they can actually deliver it before they actually fund it.
Oh,
And
good
they
plan.
also, good idea, right? And they also provide logistics and supply chain backend services. So basically, once you've finished building your stuff, you don't want to sit there and pack and ship 1,000 envelopes with T-shirts or parts or
A
whatever.
lot of
it is.
Kickstarters forget how difficult and expensive that part is, and that's where they get burned.
Extremely tedious and very expensive. Yeah, there's a lot of
Especially if it's
Kickstarter-
outside, if you ship outside of your own country, it's very expensive.
Yes. And so Crowd Supply has a great negotiated shipping rate. They have a fulfillment warehouse. They have a whole e-commerce backend. They can take pre-orders. They deal with customer support, tier 1 customer support. So where's my order? My credit card didn't go through. I changed my address. They handle all of those things. And in addition to all the other backer stuff like updates and bits and pieces like that. So in terms of, it's just Sean and me, running this show. We didn't want to hire an e-commerce guy or logistics guy or packing guy or all this sort of stuff. And so really Crowd Supply enables hardware innovators to be like, great, I've built something. Here's 500 units at the dock of the factory. We mail the whole pallet to Portland, Oregon, and then Crowd Supply takes care of the rest. Done.
Okay.
Great.
Nice.
And also, now that the campaign is over with, to a certain extent, the GoFundMe page has turned into, oh, yes, I'd like one as well. So it now becomes a storefront instead of a funding thing like it was before the campaign finished.
Yep.
So you can actually go to our campaign page now, and I think there are still some boards available for purchase.
Yep.
Okay, so it evolves from I need funding to now we are a business, which often happens with the Kickstarters that do succeed, but this site seems like it gives you a good path to that. So there's no transition really, it just goes right into
Right.
it.
Yeah, the weird thing about Kickstarter sites is they have to actually swap out a link at the very last minute and say, from our Kickstarter site, go to our store. This one's literally the same site, but anyways.
What was the biggest challenge that you came across? So you had the design first, and then you had to get it manufactured, obviously? And you had done that before you went to the crowdsource?
Yeah, I mean, so we actually, because this was sort of a backwards thing where the crowd sort of convinced us to build it, we actually had built functional laptop prototypes. So we brought with us to CCC, and I think it was Hamburg that year, Sean, right?
Yeah, it's Hamburg.
Yeah. And we gave a talk on the stage, and the cameraman was taking pictures of this laptop, and the crowd was like, "Oh my God, someone built their own laptop. We want one of these." And so we had fully working vetted hardware by the time we went to fund it. And before we funded it, even we also had the new design with the case opening backwards and all that sort of stuff was also done in a first cut prototype sense. Quoted with the factory, went through design for manufacturing test, and we had a really good sense of our costs prior to going in, which is part of the reason people complain that it's fairly expensive for what it is, but we actually saw all the costs and we knew what it would take, and we just had to sort of bite our teeth and be like, look, I'm sorry it's this expensive, but that's what it costs to build a laptop in Quantity 500.
Well, the alternative is you pull a number out of your butt and then you run out of money to build it halfway through, and that happens a lot.
Right,
That's the thing.
right.
That's a tip of the crowdsourcing, and obviously that's why you guys succeeded. You developed it on your own time and dime, and then you made it.
Yeah.
Because then it's kind of turnkey. I mean, did you feel that it was fairly turnkey when it was time to go? You're like, okay, we just basically need the money for a mass order. Were there a lot of challenges that cropped up once you jumped up to that level, or what was the biggest challenge?
Well, by the time we went to mass production and crowd supply, we had already been. It was a third version of the main board, but there were a lot of boards that we hadn't done, and we didn't really have a factory test. This is a thing that everyone forgets: is that it's being done in a factory in China, and you have to test every single board as it comes off the factory. Actually, I'm sorry, that's not correct. This was done in a factory in the U.S.
Fremont, yeah.
Fremont.
Yep.
But
So-
still, you need to test.
You had the main board, but you're talking about the ancillary boards you hadn't finished yet?
So, right. So the main board had gone to the third rev, but the front panel bezel configuration where the little buttons are, we hadn't settled on exactly what that configuration cluster was. A very small detail that had yet to be settled. Yeah.
So we still did have to do the factory test and some of the ancillary boards, and write all the tests and get all that vetted. And I think the plastic still needed to be done because at that point we'd only had 3D printed prototypes. So there was some work left to be done, but at least the electronics were mostly vetted.
Yeah. And there were plenty of problems around the molds where, like, you know, when the first molds came out, the case was warped. We had to do like reliability testing on the hinges of the case. So we actually paid a guy to open and close the case like 2,000 times, and then see what part broke first. And we found out we had to go from aluminum to stainless steel at one point on a couple of the like. There's a bunch of little things that we had to go through, and on top of that, you know, going to do a run of 500 or 1,000 of these pieces, we had material shortage issues. We had lead time issues. We really wanted to deliver on time. And for example, one manufacturer was like, oh, all of a sudden 16 weeks for this part, way too long. And so we had to like second source a part, qualify another vendor, all this, like just things on tops of things. I wish it was turnkey. It was supposed to be turnkey. It was still a lot of effort. Yeah.
Well, it still sounds like it went better than it does for a lot of people.
I
I get this.
All we had to do was production. That's it.
Right. This would lead into my next question. So we talked about the old 8-bit computers and what you do now with the Novena, but what were you guys' background before you started this? Or what is your day job, or has this become your day job? Maybe just a little bit of your slightly prior history.
Yeah, Sean, you go.
Well, before this, both Bunny and I worked at Chumby making smart digital alarm clocks.
I remember
So,
that thing.
yeah, Bunny did the hardware and I did some of the firmware, particularly for the Chumby 1, which was the cost down revision of it. And that was my big introduction to Linux kernel development, driver development, a lot of embedded stuff, bootloader development. And from then on, we moved to NETV, which was a video product. So we've been in the embedded ARM space for a long time. And it seemed like it was finally time to move to something and design something for ourselves where we wouldn't have to cross-compile ARM code all the time. We could just compile native ARM code, which made development of other platforms a lot easier. I had to update NETV earlier, and it turned out to be easier just to copy the entire route to my Novena and work on it there natively than it was to either cross-compile somewhere else or do it on the NETV, which was much lower powered.
Oh, that's interesting.
Yeah, that seems pretty reasonable.
Yeah. So that was part of your reason for building this.
Yeah, we wanted to build something that we would use every day. I mean, for me personally, as like a hardware guy, I live in these really tiny boxes for cost and size and whatever. Like some marketing guy will come with a spec and say, "You're going to build this thing. It's going to be great." I mean, like, really? I would never use this in 1,000 years. But okay, you're paying me, right? You know. And I was like, all right, how about how about we build something that I would like to use, right? And then and what Sean would like to use, and that's where this kind of came from. I mean, that's probably the reason Novena has a kitchen sink in it. Is like we just threw every freaking feature in there that we were dreamed of.
Yeah. Speaking of that, what's with the FPGA? What is that intended for?
Why not? Who
Okay.
wouldn't want an FPGA in their laptop?
Well, it's kind of
right?
an expensive part. I just was curious. Don't they have?
Yeah, I mean,
Oh, go
Go
on.
ahead.
Go on. Go on.
no, I mean, one of the things that we really want to be able to do is to use the Novena for like it's a platform for us to do other things, right? So, for example, if we're trying to do, like, we wanted to do an analysis of SD cards at one point in time, right? And we need to do some really low-level protocol hacking on it, and we wanted to snoop pins on the ROM and that sort of stuff. Normally, you have to build like a custom board and plug it into this thing and go to Raspberry Pi or whatever's
But
blah,
with an
blah, blah.
FPGA,
Like, with an FPGA, we just plug it directly into Novena. Like we would try, for a while we had like a little mobile phone mounted inside of our Novena that we're directly hacking by like emulating the boot ROM through through interface on the FPGA, all this sort of stuff. And it's the same freaking laptop because we just carried around. It's not like you had to travel and carry like a JTAG box, this other box, and this wire that plugged into this USB thing, this other stuff. You just fold it close, we throw it in the luggage, and we go, and we'd sit down and we did hack in the airport and get embed development done, which is, I mean, I think it's great.
okay, I guess that leads into my next question is, so you've obviously shipped quite a few of these. I mean, Felix has one, so everyone must have one now. Is that how that works? Well, anyway, I guess, what are some cool projects that you have seen done by other users? Have people really gotten to dig into them yet? What have you seen in the community? Or do you just, they're like, oh, I don't care anymore, it's done, I never want to see it again?
No. I mean, I'm pretty excited that there seems to be some people using it. I mean, actually the project funded with a community effort. There's this group called Myriad RF who's doing a software-defined radio, and they've actually built the custom hardware card that plugs into the FPGA and can do like a SDR front end, and they hack the FPGA and build like kernel drivers and all that sort of stuff, and they're still banging away today at it. It's pretty cool. There's another group, Cryptic.is, that has been trying to prototype, a bunch of cryptographic primitives on Novena, and they built like a true random number generator from a noise source that plugged in the FPGA front. There's the autonomy cube. There's actually an art display. I think it's in Berlin, Sean,
I
right?
think it's in Madrid.
Or Madrid, yeah. Jacob Applebaum and a couple other guys worked on this, and they took some Novenas and put them together and built a Tor exit node out of it, which is now on display in an art museum. It's called the Autonomy Cube, and it's routing Tor traffic to the world as an exit node. So I mean, people have been doing some interesting things with this for sure.
Yeah, we also get people who post pictures in our forums of cases they've done.
Yeah.
There's some 3D printed fan ducts on Thingiverse, I think, or some of the other 3D printed houses that they've gotten done either with their own printers or through Shapeways. And I've gotten some just kernel patches, and software patches, things like that, which I'm always delighted when people send me patches because it means that they're finding it useful and they're contributing back to it.
All right, well, thanks again.
Okay. All right. See you guys around. Thanks for interviewing us.
Take care. Have a good day.
Yep. Bye.